Dear students, we have discussed about the architecture of 8086, and in that architecture till now we have discussed about bus interface unit, that is BIU, which is used to connect microprocessor with the external world. Now in BIU, once the instruction is fetched in the instruction queue, then this instruction must be given to the execution unit. So the section below this dotted line is called execution unit. These are the parts of execution unit. First we will discuss about this section. This section consists of several 16-bit registers. These 4 registers are stack pointer, base pointer, source index register and destination index registers. What is the use of these registers? These registers are used to store offset addresses which are required for the calculation of physical address of the memory location. Complete physical address of the memory location. Now what is the physical address? So as we have discussed in the BIU, bus interface unit, that this arithmetic circuit is used to calculate the physical address. Now how it can be calculated. So as we know that the physical address of the memory is of 20 bit, that is 1 megabyte, and all the registers are of 16 bit. So therefore to calculate physical address, the formula is physical address is equal to 10 into base address plus offset address. Now base addresses are stored in the BIU different registers: extra segment, word segment, stack segment, data segment, and offset addresses except instruction point. Offset addresses are stored in instruction pointer, source stack pointer, base pointer, source index register and destination index register. So these 5 registers, these 4 and instruction pointer are used to store the offset addresses, and base addresses are stored in these segment registers. The complete memory is divided in 4 segments, each of 64 kilobyte, and offset addresses are stored in these 5 registers. Above this part there are 4 general purpose registers. These AX, BX, CX, DX are called general purpose registers. Suppose that we have to store any data on which any operation to be performed, or after any arithmetic or logic operation the result is to be stored, then where it can be stored? It can be stored in the general purpose register of 8086 microprocessor. So these are general purpose registers: AX, BX, CX, DX. These registers are divided in 2 parts, each of 8 bit. So AHAL, BHBL, CHCL, DHDL. So you can say that there are 4 16-bit general purpose registers, or 1, 2, 3, 4, 5, 6, 7, 8 8-bit general purpose registers. In 8086, ALU has the capability to perform arithmetic operation or logic operation on 8-bit as well as 16-bit data. So therefore, there are 2 types of general purpose registers: 8-bit and 16-bit. If we consider 8-bit registers, then there are 8 8-bit registers, and if we consider 16-bit registers, then there are 4 16-bit registers. Okay. Now, what is the use of this control system? This control system, it is just below the BIU, and when any instruction is given from instruction queue to execution unit, first is it pass through this control system. The main function of this system is to decode the instruction. Suppose that any instruction is fetched from the microprocessor, it is in binary code. So the machine or microprocessor must understand what is the function of this instruction, and that understanding can be made with the help of decoder circuit, and that decoding operation is performed in the control system block. After decoding the instruction, the relevant operation which is to be done, corresponding instruction is to be given by this system to the ALU and remaining blocks of the execution unit. So as we know that instruction consists of two parts, opcode and operand. Suppose that opcode and operand. Suppose that we are considering a instruction move ax comma bx. Now in this instruction can we see any operand? No, there is no operand. This instruction consists only of the opcode. So this instruction must be given to control system for decoding purpose, and then after that we have to perform simply transfer operation, and there is no arithmetic operation needed. Suppose that another instruction like move ax comma 2000h. It is somewhat different from 8085. In 8085 for immediate data transfer we use MVI instruction, while in 8086 for immediate data transfer or for the data transfer between two registers, same instruction can be used. So here this instruction is used to transfer 2000h in register pair AX, that is AH and AL. So here this part of the instruction is opcode and this part is called operand. So suppose that this instruction is given to the execution unit. The opcode part must be given in the control system block, control circuit block, and the operand part is given to the to this address bus so that it can be stored in the general purpose register. Suppose that any other instruction like add bx comma, suppose that we consider it bl comma 05h. What does it mean? It means that we have to add 05h in a register BL and result will be stored in register BL. These instructions are different from 8085 and we will discuss it later on. Here you can understand it in a way that 05h is added to the content of register BL and result will also be stored in register BL. Okay. So now this instruction again has two parts. This is opcode and this is operand. So when this instruction is given to the execution unit, the opcode part is given to the control system and operand part is given to this address bus. So that an operand part is given here, like 05h is to be added. It must be given to the ALU, and after when control system decode this instruction and microprocessor understand that ALU has to add 05h to the content of BL. So here the content of BL must be given through the address bus. So here what is the content? Content of BL is given to this ALU and these two contents are added, and the result of these two additions will be given through this bus, A bus. A bus is what? Data bus. A bus is not address bus, it is data bus to this general purpose register. So it means that the control system's use is to decode the instruction as well as to instruct the execution unit's remaining part to do the corresponding action, to perform the corresponding action. If the transfer operation is to be performed, then there is no need of ALU and data is transferred between the registers. Suppose that any arithmetic or logic operation is to be performed, then the role of ALU is there. Below the ALU there are two registers. This is called this operands is temporary register. This is temporary register. What is the use of this temporary register? This temporary register is used to store data temporarily for a very short time duration. Suppose that any instruction XCH G BX comma CX. This is exchange instruction. This instruction is used to exchange the data between registers BX and CX. These two are 16-bit registers. Now, how it can be exchanged? Suppose that we replace the content of BX by the content of CX, then this content will be lost. For the safety of data, first we transfer the content of BX to this temporary register, which is called operand register. Then now content of register CX is transferred to BX, and then this temporary register's content is given to register CX. So what is the use of this temporary register? The use of this temporary register is to store the data temporarily, this operand register. Below this, there is a flag register. Flag register is used to show the status of any arithmetic or logic operation. There are 9 flags in 8086, which we will discuss in detail later on. Thank you.